This is a video submission for lab number 6. Move forward straight using the encoders. This device, we have our code. I'm going to hit upload in the top right. Compile sketch. Uploading. Uploaded. So our robot continues on. When this green LED turns on, we know this robot is ready to run. We go ahead and remove this cable and we place it on our starting line. Our wheels are placed in alignment with the front of this piece of tape, right down the middle of it, and then I'm going to straighten it out. On the opposite end, we have another piece of tape that is our 36-inch mark. When we hit button A, it'll be a 2-second delay as requested, and then the robot will move forward and stop right on the 36-inch mark, and then return back to its original position. Again, if we want to run this again, if we hit the button A again, it will continue with the same behavior, do the 2-second pause, continue to the end, and then return to its original position. Coming back to our code, we have a number of functions. At the beginning, we have our magic numbers, and we've initialized all of our variables. And due to some weirdness with our compiler, it required us to use prototypes. We went ahead and set them up here because that was our requirement. In the lab requirements, we had to put our functions at the bottom. So we have setup. We start a serial monitor. We give it a second delay, and then we turn the green light on. So this is what we were waiting for with the robot. Here, we wait for button A, turn the yellow light on to tell us the robot is running, and then we delay for 2 seconds. Once that is done, we move into a loop function, which first moves forward for our distance to be traveled, which is our 36 inches. We went ahead and converted that to centimeters, which is 91.5. With this, we use our drive straight function. It waits for 2 seconds, begins moving. It checks if our distance is forwards or backwards using a basic if-else statement. Then grabs our encoder counts, and while our robot has not moved the encoders to reach our encoder count, we go ahead and move our robot. We have a little bit of a balancing act here, where if the encoder values between the two motors start getting out of sync, we go ahead and up the speed of our left motor or reduce the speed of our left motor as necessary. And the same for the right motor, obviously doing the opposite of the left motor in order to bring us back in line. This brings us to within about 30 pulses of accuracy within. This keeps us within about 30 pulses of accuracy, which was more than what we needed for this assignment. In order to calculate our pulses required, we use this function called count for distance, and that's called within our drive straight function. So we move forward, then we move backwards, and then we send some debug statements, and then we wait for the button A to be pressed again. Once it's pressed again, it will allow us to continue down this code and loop back in the forward, and so that's how we do our continual running while waiting for the A button.